Hello guys, it's Sam. So in today's video, I just wanted to go do a couple practice questions for AP Statistics because today is April 15th and that AP test is coming up soon. And I'm just going to, well, practice. So last year I found this thing called AP on Crack. And the questions were just so hard that it actually came around to become good practice. And I hated it, but it was helpful. I will admit it was helpful. So I wanted to make like a couple practice AP videos. In the next couple of months, I'm going to be taking lit, chemistry, BC Calc, obviously stat, gov, and econ. So I'm probably gonna make videos on lit, chemistry, calculus, and I'm doing this one now. Gov and econ, let's be honest, bro, no one really cares about those. So, all right, but without further ado, let's start. Let's start the epic uh thing. So, practice test number one. Oh, there's a lot. Wow, dang. I have my calculator with me, my TI Inspire gas. I don't really have a good way of showing it, but oh well. All right, so this is practice, multiple choice practice test. This is multiple choice practice test questions, specific confidence intervals. Huh, these are downloads. All right, we'll see. Let's just start with the first one. All right, an outlier is an observation that significantly different. During flu season, the medical study center needs to keep a large supply of the flu shots, and nurse aid compiles data on the past few years during flu season. The cumulative probability chart shows. It says cumulative. Cumulative. How many flu shots should the center store every day to 95% demand? So 95% is here, and and then you follow this down. Looks like 190. A large company has how many questions? 10 questions. Not bad. A large company has offices in two locations, one in New Jersey, one in Utah. Mean salary of the office assistants in New Jersey is 28K. The mean salary of the assistants in Utah is 22K. And office 120 office assistants. Utah is 32 office assistants. What's the mean salary paid for the two locations? Mean salary paid. Okay, so then we just do 28.5 times 128, and then we do 22.5 times 32. So then 128 plus 32 is 160, and 3,648 plus 720 is equal to 4,368 divided by 160, which is 27.3K average. In the northern United States, schools are sometimes closed during winter due to severe snowstorms. At the end of the school year, schools have to make up for the days missed. The following graph shows the frequency distribution of the number of days missed due to snowstorms per year, using the data collected in the past 75 years. Which of the following should be used to describe the center? So it's obviously skewed. Um, well, we can't use a mean because it's skewed. But I think median would be a pretty good choice because it won't be affected by like the skew. Because then this is 5, this is 1. It'll be evened out. So, man, it's been a while since this unit. The probability that there'll be an accident on Highway 48 each day depends on the weather. If the weather is dry that day, there's a 0.2% chance. If the weather is wet, there's a 1% chance. Bro, I thought it'd be like 10, 20%. Today, the weather station announced that there's a 20% chance of weather being wet. What's the probability that there'll be an accident? You just multiply the you just multiply the percentages. So if it's wet, then there's a 1% chance. Let's see, right? 20% chance of it being uh wet within that. So if this is 100%, then there's a 20% of that, and then there's a 1% of that 20. It's a 1% of that 20. So if we so it's just 20 divided by like 100. Yeah, let's see. It has to be. An employment placement agency specializes in placing workers in jobs suited for them in the past experience, and the agency knows that 20% of all workers places will no longer be at the position which they placed after 1 year. However, only 5% will be on that position as 1 year. At the start of the year, an employee hires 100 workers using this agency. Then at the start of the next year, the employee hires 100 more. How many of these 200 workers are expected to be on the job at the end of the second year? How many of these 200 workers are expected to be on the job? Okay, so 20% of all the workers will no longer be in the position. 5% of those remaining, bro, this is like some math gymnastics. Yeah, it requires actual mental. At the start of the year, employer hires 100. Then the next year they hire 100 more. How many are expected to be at the end of the year? 20% of the workers' places will no longer be at the position they were placed after 1 year. So 20% of 100 is 20 people. So we take away 20 people. So we start with 100, we minus 20. However, 5% of those remaining after the first year will leave during the next year. The agency knows that 20% of all the workers it places will no longer be at the position they were placed after 1 year. How many of these 200 workers are expected to be on the job at the end of the second year? Will no longer be at the position in which they were placed. Does that mean they're still in the company, or like, however, only 5% of those remaining the first year will leave the next year? 100 workers, so minus 5 again, and again, 100. So that's 200, that's 175. Wait, I don't really get this problem. I don't like this problem. We're going with we're going with we're going with we're going with D. Alright. The average number of calories in Yum Yum Good candy bars is 210, with a standard deviation of 10. If the number of calories per candy bar is normally distributed, what percent of candy bars contain more than 225 calories? Standard deviation of 10 calories. So if we drew the best fit, alright, so standard deviation of 10. Oh man, this is like the empirical rule thing. This is going to be like, if this is the mean, wait, what the, wait, no. Oh, there we go, okay, so this is, collectively, this is 13.5% or something. This is like, you know what, I'm gonna look it up. Screw this. Bell curve. You can't stop me. Alright, 34. Okay, whoops. So this is 13.6. This is 34.1. This is 2.1. And this is point. Actually, I don't think that's right. I think it's something else. Alright, so. No, I don't like this either. Whatever. And then we'll deal with it. 2.1. Alright, so. If it's 2 and 210, this is going to be 220, and this is going to be 230, but somewhere around here is 225. So candy bars has more than 225. So it's going to be, this is going to be 13.5. This is going to be the 2.1. It has to be E. It has to be E, because technically, this guy is like here. Oh, no, it's D. Alright. A publisher used standard boxes for shipping books. The mean weight of books packed per box is 25 pounds. U with a standard deviation of 2 pounds. The mean weight of the box is 1 pound with the standard deviation of the mean weight of packing material used per box is 2 pounds. The standard deviation of 0.25 pounds. What is the standard deviation of the weights of the packed boxes? Standard deviation of the weights. Mean weight of books packed. Standard boxings for shipping lists. Mean weight of the books packed per box is 25. With a standard deviation of 2 pounds. Mean weight of boxes is 1 pound. With a standard deviation of 15. The mean weight of the packing material. Oh, I do not like this question. Well, do we just add all the standard deviations together? Because this is standard deviation is 2. Then this is saying 0.5. This is saying 0.25. So then we just add that, right? It's like 15 plus 25 is 40. Plus 2? Is it this? I don't know. We'll see. Principal of a school interested in estimating the average income per family is. She selects a random sample of students and collects information about their family income. A 95% confidence interval computed from this data for the mean income per family is 35K. Which of the following provides the best interpretation of this confidence interval? 95% of the students in our school families, there is a 95% probability. There's a 95% possibility that the mean income per family in the school is between. Is it the mean? Yeah, some sample. No, we're not talking about other samples. Families of all students in the school. Per family of our students. A simple random sample of students collect information of family given the data. What's the best interpretation? This is either B or E. 90% probability that the families of all students in the school have an income between 95% probability that the mean income per family. What's the difference between this? Yeah, I think it's E because it's talking about mean income here. Like it says mean income per family, and here we say mean income per family, like right there. Wow, this is okay. but here you can see. Oh my goodness, why is this so annoying? Jeez. Wait, actually, wait, let me just see if I can actually highlight this. Bro, whatever, it's E. Okay, the Department of Health plans to test the lead level in a specific park. Because a high lead level is harmful to children, the park will be closed if the lead level exceeds the allowed limit. The department randomly selects several locations in the park. It gets soil samples from these locations and tests the samples for lead levels. Which of the following would be a type 1 error? So if we remember, the type 1 error, well, actually, no. Type 1 error would be, I saw this trick off Reddit. You go 1, false, positive. Then you go 2, type 2, false, negative. And the way you remember it is you just go this, this. This becomes an N, and this becomes a P. So, what we're essentially doing is that the false positive is where you accept it. Uh, shoot. Uh, you accept it, but it's actually wrong. And the false negative is where you deny it, but it's actually correct. So, so you false positive and you deny it when it's actually type 1. You accept the null. No, you reject the null when the null is true. Yeah, that's a false positive. You reject it when it's actually fine. So they would close the park when lead levels are within the allowed limit. Okay, that probably fails. It's fine though. So we got 3 wrong. 70. It's a fail. It's fine though. Alright, let's see what we missed. Let's see what we missed. Okay, at least 200. I call cap. My visual skills are actually top notch. So we can see that this is 90, 95. Can I draw, please? Can I draw, please? Okay, thank you. Oh, shit. Wait. Don't worry. Okay, dang, okay. Okay, whatever. So 95, which is this. Huh? Bruh. Bruh, bruh. Bruh. I put 190 at most. At most. Bruh. You need at least 200. Bruh. That's stupid, but that's fine. Submit. Yes. Oh, these stupid ads. Erase this, please. I don't want this. How do I get rid of this? What's this? Oh, yeah. Oh, I remember. Okay. So, tree diagram. What's probably this is an action. Oh, okay. I'm just gonna do this. So, there is a 20% that is gonna be wet, and there's an 80% that is gonna be dry. I forgot all about this. And with an accident, there is a 1% chance. Because all of this has to add up to 1, right? And all of this has to add up to 1. But the thing is, how did they get, um, huh. Oh, it's because, wait, no, I still don't get it. Wait, no, it makes sense. Yeah, this makes sense. Okay, so there's a 1%, so 0.01 accident. This is a 0.0, they're looking at 0.2%, so 0.002 accident. Weather condition is so they multiply these, and then they also multiply these, and they added them. Bruh, is that really it? You just multiply those like that and you add them. Stupid, but okay, cool. Let's go back. Last question. Yeah. Okay. The When you add standard deviations, you have to put it under the square root and you square them. So I was right about adding them, but the thing is, I forgot all about the standard deviation formula, which is you add them squared, and after you add them all squared, you just take the square root of them, and you get this number. Yeah, I figured that was wrong, but whatever. Alright, that was the first practice test. You're right. I only have 7 rights. I'll take the First Amendment, the Second Amendment, the Fourth Amendment, the Ninth Amendment, the 10th Amendment. I don't need the sixth, trust me. I'll take the fifth. What is that? I have one more amendment. I'll take, I kind of want uh, I want the Seventh Amendment. Did I already say that? If I said it, then I wanted I'm fine with not having the Third Amendment, to be honest. You know what? Here, how about this? I'll take away, I'll take away the 19th Amendment. All right, cool. There we go. Those are my 7 rights. I'll take away this 19th. All right, anyway. Um, okay. Let's just do this for. All right, we're back in the grind, boys. After a frost warning. Okay, and the thing is, I'm really good at FRQs because like I've always been good at FRQs because it's just like practice. You just do it. You just do like a practice thing once or twice, and you just get the idea how to do it. But somehow, like the intellectual like mind juggling of the MCQ has been getting me lately in my last couple tests at school. So I'm practicing MCQ only this video. If you want to see me do FRQ, let me know. That'd be epic. Because you're in this far into the video anyway, so cool. After a frost warning was issued, the owner of a large orange grove asked his workers to spray all of his trees with water. The water was supposed to freeze and form a protective covering on the ice. Nevertheless, the owner suspected that some trees suffered considerable damage. To estimate the portion of trees that suffered more than 50% of damage due to the frost, he took a random sample of 100 trees. What is the response variable? Oh no, this is unit 4. No. The proportion of trees that suffered the response variable. What is the response variable? What is this response variable, bro? Bruh, I'm too tired for this. Alright, So, yeah, suffered more than 50% of damage. Take a responsible. Yeah, suffered more than 50% of damage. Wait. No. Yeah, it's whether if it was damaged or not. That was the thing we're looking for. To use a census to determine the proportion of students with a learning disability. To use a census. Hmm. Red snappers? No. Engineering business? No. No. In your neighborhood? Hmm. In a high school. Probably the houses. Probably the houses. A student organization in the university is interested in estimating the proportion of students in favor of showing movies bi-weekly instead of monthly. 10 questions. Um, how many students should be sampled to get a 90% confidence interval with a width of at most 0.08? Hmm. There's like a formula for this. There's like a um you have to do like the this is for proportions, right? Yeah. So proportions goes like square root of it, it's over square root of n, and you have like standard deviation. Um, Dang, there's a formula for this. I forgot. I don't have the formula sheet with me. I'll learn it. Okay. Small kiosk at Atlanta Airport carries souvenirs in the price range of $3.99 to $29.99 with a mean price of $14.75. The airport authorities decide to increase the rent charge for a kiosk by 5%. To make up for the increased rent, the kiosk owner decides to increase the price of all items by 50 cents. As a result, well, the following will happen. The mean price and the range of prices will increase by 50 cents. Mean price will remain the same. Decides to increase the rent prices and all by 50 cents. Decide to increase the rent charge on the cost for 5%. The mean price. Yeah, it is. I thought this was economics for a second. My brain just like did the U-turns and alright, demand shifts. Shifts in demand. Alright, mean price range by 5%. Mean price will remain the same. Mean price will not remain the same. The standard deviation will remain the same, if anything. Yeah, okay. 200 students. That was such an easy question. I don't know why my mind just blanked. I must be tired. 200 students are classified by sex and hostility level. Low, medium, high. Okay, cool. Is this sexist? Let's find out. Uh, Females have a greater low hostility level in terms of number, but they also have a greater. The sample size for females are just more. They're just more females. Alright, whatever. Hostility level among students independent of their sex. How many female students would we expect to show the medium HLT score? Medium. Alright. Well, how many female students would we expect? What we have to do is that we have to add all these numbers. So 35 plus 62 plus 40 plus 50 plus 5 plus 8 is 13. 200 students in total. There's 90 students in the medium, so 90 divided by 200. That gives us some decimal, 9 over 20, which is 45%. So now we have to find out the total number of females. 62 plus 8, well, that's going to be 70. 70 plus 50 is 120. Don't need to do math for that. And plus, the males are 80 in total, you can tell. So 120. So what's 45% of 120? That's going to be 54. After receiving several complaints from the customers about the store being closed on Sundays, decided to conduct a survey. They randomly collected 100 females and 120 males, asked them, "Are you interested in shopping on the store on Sundays?" Found a number of customers saying yes. Construction 9% wrong interval. Portion of females, portion of males. Resulting interval was in the negatives. Which of the following is the correct interpretation? Okay, shoot. 95% confident that the proportion of women interested in shopping on Sundays, they are not equal. That is not a valid assertion. The men shopping on Sundays exceeds the proportion of women interested in shopping on Sundays. 95% confident that the proportion of women interested in shopping on Sundays exceeds the proportion of men. It's either women or men, it's just more. But the resulting interval was this. Because of okay, wait, no, is that a thing? Because the interval does not contain zero, the interval is invalid and should not be interpreted. I think that's it. We'll see. Company is interested in comparing the mean value of sales revenue per salesperson at two different locations. The manager takes a random sample of 10 salespeople from each location and independently records the sales revenue for each person. He decides that to use a t-test to compare the mean sales revenue for two locations. Which of the following assumptions is necessary for the validity of the t-test? 10 salespeople, t-test to compare the mean. Which of the following assumptions is necessary? Well, t-test, we don't need to know the population, but they need to be normally distributed. That is a necessity. Skeptic decides to conduct an experiment in ESP, which is blindfolded subject. 100 cards are dealt with from a well-shuffled pack, with each card being replaced after a deal. Pleasing 5% significance. That's alpha value, essentially. What is the lowest number of cards the subject needs to call out correctly in order to show that he is doing better if he was simply guessing? Okay, how many deck cards are there? Regular deck of cards. There's like 53 cards in a deck, right? Because you have 13 times 4. So is that 56, I think? 53, no. 13 times 4, which is 52. So then half of them gotta be black and half of them gotta be white. But why is knowing the number of cards in a deck important? No, it's 100 cards, bruh. Okay. Dealt from a well-shuffled pack, with each card being replaced after a deal. Okay, so this with replacement. Lowest number of cards he needs to correctly guess. It's gonna be like, mm, wait, there's another equation for this. To say that you're simply, because with a 5% confidence, it's abnormal to get, yeah, it's 95. You can get more than 95. Manufacturer of a motor oil is interested in testing the effects of a newly developed addictive on the lifespan of an engine. 25 different engine types are selected at random, and each one is tested using oil with the additive and the oil without the additive. What type of analysis will yield the most useful information? So we need to figure out which test we gotta use. See, these are the type of questions I need to practice. Because I know how to do each of the tests, but identifying what test to use, now that is something we need to practice. 25 different engine types selected at random. With additive and without the additive. What even is a matched pairs? Independent samples. We don't even need to do proportions and means. That's not what this is. You could do a chi-square test, honestly. Chi-squared? 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 Matched pairs comparison of population proportions. What is a matched pairs, bro? Chi-square test of independence, degrees of freedom. That's easy. 3 minus 1 is 2, 4 minus 1 is 3, so 2 times 3 is 6. Alright, we got a lot wrong. Let's go. I got 5 rights. You guys can have your 19th Amendment. Honestly. Okay, so which of the following would be the most unreasonable to use as a census? Unreasonable, bruh. Bruh, unreasonable. Oh my gosh, bruh. Okay, I don't really count that. We don't count that. Gotta read, bruh. Okay, so this is the formula. So this is for percent. How many you need? Oh wait, margin of error. Oh, cause when you're on the table, right? You gotta get both sides of that confidence interval thingy. So, cause it's like you have this curve. Here you go. You have the curve like this, and then there's stuff on both sides. So what they're saying is that all of the red is equal to 0.08. You gotta divide by 2 because it's 1, 2. So it's 0.04. Our value is 10%. So if you P is 1/2. Hmm. What formula is this? What formula is this? Okay, this is the z-score thing, right? Oh, this is like, wait, I vaguely remember this. So this is for, uh, um, actually, I'm gonna wrap up the video after this because I'm kind of tired. I was hoping to do like 4, but you know what? I'll come back later. I'll come back later and I'll do a part 2. It's fine, it's fine. Um, so obviously, and you need to round up because it's people. But this, so we just do n, and we have our z-score thing, which is 1.645. It's going to be on your table B, I believe. It's either table B or table. I think it is table B, and you have to check on the bottom, which it goes to infinity, and whatever is like 0.1, no, 0.9. It's going to show this 1.645. It'll be there. You have to check the infinity column on table B. So we take that, divide it by margin of error, which is 0.04. And the thing is, students sampled Bi-weekly instead of bi-monthly. So since there's only two options, that's why it's 1/2. Oh, is it the Z table? Oh, I don't know. We'll see. So we want 1/2, and then the other option, which is also 1/2, and this is going to give you an interesting. Okay, this one. Several complaints. I frick. These questions are bothering me. A. We are 95% confident that the proportion of women interested in shopping on Sundays exceeds the proportion of men. Okay, why? The entire interval P of n minus P of m falls below 0. This indicates that, oh, I have to read the question. 120 mil. He counted the number of customers saying yes, and subtracting the proportions of male from the proportion of female from the proportion of male. Oh, and because both because both numbers are negative, there's evidence to prove that more females want to have Sundays open rather than the males. I completely misinterpreted that. My bad. I forgot, but now I remember. This is why we practice. Alright, two more. Hypothesis in this experiment. Oh, yeah, it's the Z score. Okay, let's do this. 5% levels of significance. So, you don't need to write the null and alternate, it's a multiple choice, bro. So he goes, this is for proportions, or this is for proportions, yeah. This is a z-score for proportions, p minus 0.5. Okay, I remember. So it goes like z-score for proportions. Sorry, my handwriting is terrible. We go z is equal to, no, I can't write, man. Let me just try to memorize it. So it goes, because it's technically given minus actual. So whatever proportion they give minus the actual, and then we have our thing, which is p times 1 minus p over. This is on the formula sheet, so I don't really need to memorize that part. But z-score is pretty much this. I forgot. And yeah, so this is the given, because what's like half percent? So half of it's black, half of it's white, no, red. We're trying to find that p. So technically, the thing we really only need to calculate is this, because this, it's this thing. It's this thing. Where did I get this 0.5 from? I need to review this. But actually, I'm going to use this. So 0.5 plus 1.6. Oh my goodness, 1.645 square root of 0.5. 1 minus 0.5 over 100. All this is equal to 0.5823. All right. Interessant. Okay, so this value is telling us that he needs at least this many cards, 59, to prove that he's not guessing. Okay, okay, makes sense. Last one. Manufacturer of motor oil. Oh yeah, what test do you use? B, which is the matched pairs comparison of population means? 25 different engine types selected at random. Each one is tested using oil of the additive without the additive. Okay, let's find out why. Because the question is asking about the lifespan as a whole, not the number of engines. I'm testing only the lifespan. Okay. The mean is more appropriate than a proportion. Okay, because we're dealing with a number then. A mean. A lifespan. Both engine oils, with the additive and without the additive, are tested with each car. Therefore, each car is acting as a block. In other words, each car is matched with itself. 25 different engine types with random was tested using oil and without oil. So it's a block. It's being matched with itself. Alright, I have to just have to review what the different types of tests are, but essentially, yeah. So I'm gonna be posting more. These videos aren't really like meant for like watching value, because again, I don't care about being a good YouTuber. What I care about is studying and learning the content. And this helps me learn. It's also a documentation of the practice I've been doing as a student, which is, self-satisfying. It's intrinsic. Also, I can show this video to people and say, hey, look how I studied. This is what I did. Well, it's part of what I did. But essentially, yeah, I'm going to be posting part two for statistics later. I'm going to go have some lunch. See y'all. Bye.